Hello, everybody, and welcome to this release webinar on Comsof Fiber 20.1 and 20.2. During this webinar, we'll go over some key new features of these two releases. We'll go through a presentation and explain new functionality with some screenshots, and also show some videos where you can see the functionality in action. This webinar will take around 45 minutes, and afterwards we'll be sure to provide the recording to you. My name is Jonas Versteft. I'm a product manager for Comsof Fiber here at Comsof, and I'm joined here for the presentation with Chinmay Sharma, who is an account manager. So during this webinar, we'll show some functionality of both version 20.1, which was released in March, and 20.2, who is set to be released end of this month or beginning of next month. So here you can see an overview of the different functions that we'll zoom into in this webinar. And so this is an overview of all the functionality, and we'll go over this in the next 45 minutes. So first off, Chinmay will take it off and explain a bit about how you can update your workspace using our software.
Thank you, Jonas. So update allow our users to update the existing input files after creation of the workspace. So you can either replace these input files with a new file, or you can add new files to this existing files. For example, if after the survey you want to replace the old files with the new files, then you can achieve that. Or you can extend your workspace using this update feature. And all this can be achieved in a single window. So all the input files in a single window can be updated. Let's see how it looks in our software now.
Here we have demand points data that needs to be replaced after the field survey. First, we need to click on Configure Comsof Designer plugin button. In the following dialog box, we need to click on the Update button that will be used to update the workspace. Then a dialog box will appear that looks similar to the Creating the Workspace dialog box. It has just two changes. One is Overwrite Files button that will be used to replace the file, and another button is Add Data to the files that will be used to add data to the existing files. So first we need to choose the file that we want to replace our old demand points file with. We have to click on the Browse button on the demand points. We need to choose the file we want to replace. After we have chosen all the files, we need to click on Overwrite Files button. Only the chosen file will replace the current files. All the other files will be left untouched. So now we have new demand points file. Here you can see some of the location of some of the demand points have been changed. Some multiple demand points have been merged into one. So that is the field survey data which has been replaced by the initial demand point files. Now to add the files, we have to return to the same dialog box of Update the Workspace. Now we have to choose the file that we want to add to our existing demand point file. After we have chosen the file, we need to click on Add Data to the Files button. So again, only the chosen file will be added to the current files. Others will be left untouched. So as you can see, there are new demand points added to our already existing demand points. So that is how you can update your workspace, by either overwriting the files or by adding to the existing files.
Now Jonas will tell you more about optical budget in our software.
So what we did in version 20.1 is we added functionality to calculate the optical loss throughout the fiber network, taking into account the loss of splices of your fiber cables, splitters, and connectors. So in the software, it's now possible to do that calculation. So you can configure all of the loss characteristics of these pieces of equipment, and so the software will do the calculation following the complete fiber path. This is we decided to add this functionality so that it's easier for you as a user to identify locations that don't have sufficient optical budget. So based on the calculated optical loss, you can then make a decision to use a different split ratio or to include the MOM points in a different feeder cluster so that they get connected from another central office. So for this, we added a configuration pane in the comment section. So it's the optical budget section, it's called. And so here you can specify the loss for cables, splices, connectors, and splitters. And so the type of splitters that you have configured in your design rules will become available here then to specify the loss. It's also possible to configure the top layer to start the loss calculation from. So that's the top configuration. Right now, this is set to feeder. This means that the backbone equipment, so backbone cables and splices, will not be taken into account for that loss calculation. As a result, we output this information in the design. So there's an additional attribute called optical budget, which shows the calculated loss, taking into account the cables and splices and the equipment that you specified. This will be available also on every layer of the network, so not only in the MOM points, but also in the drop points and distribution points and feeder points and so on. This makes it easy to then also add some styling maybe on that optical budget to identify locations that might be in risk of not having sufficient optical budget. Next topic is also something that we added in 20.1 and we continue to work on. It's our cloud platform. So what we did in 20.1 is we made it possible to offload calculations from your local system into our cloud platform. You do need a particular set of credentials for this to get access. And once you have those, you can start using it. So the main advantage is that you can start a calculation overnight on the platform and then come back in the morning and load it back in. If it's a calculation for a large area, you can do that straight from the plugin. So you can schedule those calculations straight from the plugin in ArcGIS Pro or in QGIS. And every input processing step or calculation step is supported. So you could do a batch processing on a complete area straight from the plugin on our cloud platform or do a calculation. Now, if you have credentials for this, you can configure these in the rules settings. So when opening the design rules and under settings, you can do configure Comsof Cloud. You can fill in your username and password here. To acquire these credentials, you can talk to your account manager or contact our sales if you want to test it out. So once this is set up, you can start a calculation or input processing step straight from the plugin. So for this, we have an additional button that's added to the plugin called Cloud Execution or Toggle Cloud Execution. It's on the left-hand side. And when you click this and you click any other input processing or the calculation button, it will start transferring the data to the cloud and start the action there. So what will happen is you'll get a progress window as you normally get when you do any of the actions. When you do calculation, it will check whether license is available. If not, then you'll be prompted to create one. It will also check whether rules are available and so on. So all these pre-processing checks are done. And once these steps steps are done, the workspace is uploaded and the calculation has started. So this will prompt to open the state manager, and there you can follow the progress of your calculation. You can also just close the workspace if you're at the end of the day, just close up your laptop, the calculation is running on the cloud, and then the next day open the state manager back up and see what the status is. So in the state manager, you can follow the progress. Once it's done, you will be able to download it from the state manager, and you can load it back up as you would be able to do with any of the states. Similar as if it would be a calculation that has been done locally. So after loading it back up, you can continue to work on your area, continue processing or making changes, continue your work. Now, the additional feature is the zoomable warnings, and Jimmy will explain a bit more about that.
So for our warning panel in the QGIS and ArcGIS, now we have a single panel for our warnings. And in this panel, we'll have both input and output warnings. Both of them will have their separate tab, which will display the warning, which will display the description of the warning, and it will also display either the ad IDs of the warnings or the location of the warning. So the difference is now these warnings are interactive. So when you click on a location of a warning, it will zoom the map to that particular feature which is affected by that warning. Either a red blinking box will appear on top of it, or it will be shown highlighted in yellow. So that makes it easier for our users to isolate that particular feature on the map. And it also allows a quick access to the map, make changes to that particular feature to eliminate that warning. So with a single click, the affected features can be easily identified on the map. So now let's have a look at another feature, rollout in phases. So our rollout in phases is an extension of our old feature, which was connection attribute in our demand point attribute table. It's an extension to that. Earlier, our software used to calculate a partial network according to the value of connection attribute, but it never used to place cables and ducts accordingly in the connection attribute. So if you have placed a value where the software is not supposed to place distribution cables, then it will not place that cables. But now what we have done is we allow our software to calculate the complete network, to place the complete network, but it separates the network into phase 1 and phase 2. And these different costs are easily shown in our bill of material according to the phases. So this allows our users to have a clear overview of the cost per phases. They can easily identify which infrastructure is placed in phase 1 and which infrastructure is placed in phase 2. Let's have a look how it looks on our software.
For phase rollouts, we start by assigning connection attribute to the demand points. Here in connection attribute, you see the selected demand points have a value no drop, no dist, which means that the drop cable and ducts and distribution cable and ducts will be built in second phase. And for the rest of the demand points, it will be built completely in first phase. As we can see, these demand points are located here. So after assigning the connection attribute, we calculate. So now in our design, we can see that the distribution cables of the color orange will be built in the first phase, and the black distribution cables will be built in second phase. When we look into the attribute table of these distribution cables, we'll notice that there is a new attribute called phase, and it reflects the value 2 and 1, and that shows in which phase these distribution cable will be placed. Same goes for drop cable. You'll see the green color drop cables will be built in first phase, and the red cables will be built in second phase. And similarly, in drop cables, we have an attribute which reflects the value 1 and 2, and that shows in which phase these cables will be placed. Now in bill of material, you'll notice that there are two separate sheets. One is for phase 1 and it shows all the cost associated with phase 1. And in phase 2, we have all the cost associated with phase 2. In addition to that, we have a sheet bill of material per dp. Here you'll notice that every distribution point has an additional field which shows the total cost phase 1. And similarly, you'll have distribution point where the total cost phase 2 will be reflected as well. And here we have a distribution point where we have a total cost phase 1 and all the different costs, and total cost phase 2 and all the cost in those phases. And exactly similarly, we have bill of material per central office, where we have total cost phase 1, and then we have total cost phase 2. So for the phase rollout, the first thing we have to do is assign the connection attribute, then calculate, and then there will be a phase attribute in the layer cables ducts, which will show which phase that particular feature or that particular cable or that particular duct will be built in. In bill of material, you have two different sheets, one for phase 1 and one for phase 2. In the sheet of distribution point, you'll have an additional field which will show phase 1 cost and phase 2 cost, similarly for central office.
Now Jonas will tell us more about brownfield.
Yeah, so in the latest version, we've added some additional support for brownfield deployments. So if you have existing infrastructure, existing pipes or existing cables, existing structures, these could already be loaded into the software. But in the new version, we have extended that functionality. So now you can include existing closures and its connections to other structures or the connection to existing fiber cables. And this connectivity will be used during the deployment, during the design of the network, and will be reflected in the design output. It's also possible to now link structures to specific existing cables. Before, it would get a connection from structure to a cable to the closest cable that is within reach, while now you can specifically for particular structures indicate with which cable it is actually connected, so that you can reflect the real situation from the field in the input data. It's also possible to specify cable diameters now, and the software will check if it fits in existing pipes and adjust the routing. And we added some extra capabilities to specify whether in existing pipes a new duct should be placed or not. For example, you can have different types of pipes available to you for the deployment. And it could be that in some pipes you need to place a new duct before you can place the cable, while others have microduct slots available where you can place the cable directly. The reason why we were investing so much time in brownfield is that we see more and more fibers being deployed. There's more fiber infrastructure available, and for new deployments, it's key to reuse this as much as possible for your design, so that you can lower your deployment costs. I'll now start a video to explain what this looks like in the software and how you can use this.
In this version, we've added some extra support for reusing existing infrastructure. So you can load in existing closures that can be reused. You can also give some extra input on how all the infrastructure is linked to each other. And so that will be preserved when doing the design. So So to load in existing closures, you can specify them in the in-access-structures layer, or you can add an in-closures file as well. And so here we have a closure. So the type is set to closure, and this closure has a GIS tool ID. This GIS tool ID will mainly be used for linking all of the infrastructure. We can see here that it has an encased attribute, so it's encased in structure 9. And so we find this structure here. So this structure, this is a manhole with GIS tool ID 9, and so the software will know that these are linked together. Now, you can also link the access structures and closures with existing fiber cables and existing pipes. And so here we see this existing cable has the linked IDs 9 and 11, which is this manhole and this closure. And so there will be a transition between the manhole and the existing cable. Here, the cable doesn't contain these structures, so only 1, 2, and 3, and so no transition is created. We then also see in the resulting design that the feeder cable is reusing, well, the feeder fibers are reusing this existing cable here. And if we take a look at the closure, we will see it's an existing closure with GIS tool 11. So you know that this one is being reused. Something else that we did was give the possibility to specify on an existing pipe whether a new duct needs to be placed inside of it or whether the cable can be placed directly into the pipe. Now, if we switch back to the input view, we can take a look here. We have an existing pipe here, which has the place duct attribute set to false. This means that a cable will be put directly into the pipe. And here, the place duct is set to null, so the value is not filled. This means that the rule from the design rules is being used. And that is set to placing ducts into the pipe. Now, if we take a look at the design, then we will see the cable is routed here and here. So it's reusing the existing pipes, and we find a duct here. If I click here, I don't find a duct, so the cable is put directly into the pipe. Now, a last feature that we added was made it possible to specify the cable diameter. So the cable diameter can be configured for each layer. So take a look at the feeder layer here. We see here we have a 12-way, 48, 96-way cable, which each has a diameter 10 to 20 millimeters. And so this will be taken into account when routing the cables through existing infrastructure. Because if we take a look at the existing pipes here, we have here a pipe with maximum diameter 50, and here the maximum diameter of 5. So the cables that we added will not fit into this existing pipes, and we see here that the feeder cable is respecting that. So it's routing the cable such, so it enters the existing pipe here, even though this would be a cheaper route to use. So following this here and reusing that, it's not doing that because it cannot respect the diameter.
So now Jimmy will explain a bit how we also support splitting trenches on particular boundaries to, yep.
So from these versions, we have added 2 new input files, which can be added to our workspace while creating the workspace or can be updated later. These are line boundaries and polygon boundaries. And these boundaries are man-made and natural features like railway tracks, water bodies, lakes, canals, which require a special horizontal directional drilling. We know that horizontal directional drilling costs different than the normal trenching. And so with this, it will allow our users to integrate these boundaries to our software. Our software will consider these boundaries and according to these boundaries, assign a particular possible trench with the subtype. And these subtypes can be easily integrated into our rules and can be assigned a different cost. And this all will take care by software just based on the boundaries and a particular feature called split trenches on boundaries. Let's have a look at how it looks on our software.
To integrate boundaries in our workspace, we start by first adding boundaries as input file to our workspace, and that can be done in the same dialog box where we enter other input files. To enter boundaries file as input, the field for it can be found in advanced input files. So we have boundaries option and we have a polygon boundaries option, and these files can be added to the workspace. So the boundaries, line boundaries is visualized here. The polygon boundaries is visualized here. So when we look into the attribute of line boundaries, there are two important attributes here. One is width, that is the width of your line boundaries, that will take into consideration when the software cut a particular possible trench. It will cut the size of the width mentioned here, and the subtypes. And these subtypes will be assigned to the cut possible trench. In polygon boundary, we have one attribute, that is subtypes, that is the cut possible trench will be assigned this particular subtype. To cut the possible trench, we have to execute split trenches on boundaries, and when we execute that, the possible trenches would be split considering the line boundaries or the polygon boundaries. So if we look at the result of the split, so here we have a split trench of the length 2 meter, that is the width of the line, so 1 meter above and 1 meter below, and the subtype is assigned waterway, and that was the subtype which was assigned in the line boundaries. If we look at the polygon, then the lake subtype is assigned to the split trench. When we go to the rules, these different subtypes can be assigned different cost here. These can be imported using import subtypes, and then these particular subtypes can be assigned different costs according to the cost of a particular subtype. And once that, then during the calculation, software will consider these costs and make decisions accordingly. So that is how you can integrate boundaries into a workspace, split trenches according to those boundaries, assign different costs to that particular subtype boundaries, and then calculate.
So now let's have a look at drawn rings. So we have an old rule strategy for our ring topology, which is manual drawn rings. So we have extended that strategy and we have added a feature where the software will connect the unconnected nodes through a branch. That means that now our users only have to connect the points which they want to connect through our main ring, and rest can be left untouched, and software itself will connect those through branches. So only the main cable rings should be connected now. So this gives, it's easier, it's faster to make these rings, and the software also take care of branches automatically. So let's see how it works in our software.
For manual drawn ring strategy, we start by creating a main ring cable. For this example, we'll use feeder rings. So we'll start by adding a feature to feeder ring cables and connect the distribution point we want to connect using main cable. We'll leave the distribution point that we want to connect using branches, and software will connect them automatically. So after we have created a ring, we will get a dialog box where we have to enter the size of main cable. We have to give a number to the cable group, and we have to select the sequence. For this case, we are using closed rings. We have to press OK. So the size of the main cable we have selected. Software will use lower size cables to connect branches. After that, we have to go to rules to select a setting that will allow software to connect unconnected node using branches. We go to feeder layer. We select automatically create branch cables to uncovered bottom nodes. This will allow software to connect unconnected nodes using branch cables. So for this example, we have already calculated. Let's see the results of that calculation. So we have these 4 distribution points connected through main cable. So let's see. So as you can see, the 96 cable is connecting this distribution point, connecting this distribution point, connecting this distribution point, and so on. These 3 points were not connected using the manual drawn ring. So software has connected these points through branches using a cable size of 12. Same for this point, a branch cable of size 12. So here you saw how you can create a manual drawn ring. You can select a setting that will allow unconnected node using branch cable.
All right, so here you can see a summary of the new features that we discussed during this webinar today. So from version 20.1, the last topic was a drawn ring. So the automatic branch calculation for a manually drawn ring. We also made it easier to draw the rings compared to. We went over the new cloud platform. So you can use this to offload your calculations from your local system, free up resources. Again, if you're interested in this, please let us know. Contact me or Chinmay or sales. Then third topic from 20.1 that we added was the calculation of the optical budget. So this can help you to identify particular problems maybe in the area, definitely in rural regions, or if you have a high split ratio. Then for version 20.2, which is coming out soon, that's the main functionality is related to brownfield, so excellent support for loading in existing infrastructure and reusing that for the calculation. Also for we made it possible to update the workspace easily by adding features to your workspace. Then split trenches, so splitting trenches on boundaries like gas pipelines or railways, and also for large polygon areas, if you want to specify a subtype within that area, that's a lot easier now, so that you can take into account those costs during the deployment. Then the phased rollout, so we instead of filtering out all of the equipment, if you use the connection attribute, we add a particular phase to the equipment so that you can see what it would be, how much it would cost to roll out the equipment in phase 1 and in phase 2, and that just gives extra insights into the deployment. And then related to the warnings, so we've added zoomable warnings both for input and for output warnings so that you can easily identify the issue and fix it.